Hello, Algebra 2 students. So we've split section 7.2 up into 3 days, and this is the second day. So this is part two of the 7.2 notes. And all we're doing is we're going to go over a few more examples that we didn't go over in the first video. We're still going to be using these properties that we talked about in day one to help us answer these questions, but we're going to be focusing on a few different types of problems today. So the first example we're going to look at is number 3. In this example, we have a fraction, and the numerator and the denominator both have the same base, which in this case is 5. And remember that the numerator, even though it's not written there, we know that the exponent is a 1. So because the exponent in the numerator is a 1, and 1 is bigger than 1/3, we can rewrite this as 5 to the 1 minus 1/3. So we're subtracting the powers. So for subtracting fractions, we have to get common denominator. So we can rewrite this as 5 to the 3/3, which is the same as 1 minus 1/3. And that is equal to 5 to the 2/3 power. Okay, and that's our final answer. Okay, the next example we're going to look at is number 5. So number 5 is very similar to the one we just did. However, in this one, the larger exponent is in the denominator, okay? 3/7 is greater than 1/7. So what we're going to do this time is we're going to bring the exponent from the numerator and subtract it from the exponent in the denominator. So it'll look like that. Because the exponent in the denominator is bigger, we're moving the exponent from the numerator down to the denominator and subtracting them. All right, and because we already have common denominators, this makes our life a little bit easier. So we have 1/6 to the 2/7. But we're not done yet because we still have a rational exponent in the denominator. So we need to multiply the numerator and the denominator by a number in order to get rid of a rational exponent. Okay, so because the base in our denominator is 6, we know for a fact we're going to multiply the numerator and the denominator by something with a base of 6. Okay, but we have to get this exponent here to be equal to 1. So what do we need to multiply 6 to the 2/7 in order to get 6 to the first power? And remember, when we're multiplying powers, we add the exponents if they have the same base. So we're going to actually multiply this by 6 to the 5/7. The reason we do that is because when we multiply powers with the same base, 6 and 6, we add these exponents together, and 2/7 plus 5/7 is going to be 7/7, which is going to be equal to 1. So in the denominator, we have 6 to the first power, and the numerator, we have 6 to the 5/7. That is our final answer. Okay, so our final answer, we can't have a rational exponent in the denominator in order to get it in its most simple form. All right, and the next example we're going to look at is number 11. So in number 11, we have the cubed root of 1/5. So when we're taking the root of a fraction, what we do is take the cube root of the numerator and the cube root of the denominator. All right, so let's simplify. The cubed root of 1 is just 1, and then we still have the cube root of 5 in the denominator. So we want to rationalize. We don't want a cubed root in the denominator when we're simplifying. So in order to get rid of that, we need to multiply by the cubed root of something so we get a perfect cube in the denominator. So think about what number are we going to put under that radical. So when we multiply it by 5, we get a perfect cube. Okay, we know that 125 is a perfect cube. And if we multiply 5 and 25 together, we get 125. So we're going to put 25 under the radical here, because when we multiply, we'll get the cube root of 25 in the numerator, and then we get the cubed root of 125 in the denominator, and the cubed root of 125 is just equal to 5. So that's why we multiplied by the cubed root of 25. All right, now we're going to move on to our next example. We're going to go to the next page here, and we're going to look at number 2, which is kind of similar to the one we just did. So the first part of the problem is going to be the same as what we did in the last problem. I'm going to take the fifth root of the numerator and the fifth root of the denominator. We can rewrite these in radical exponent notation. So if we do that, remember that the number we're taking the radicand to, or the power we're taking the radicand to, which is the number under the radical, is going to be in the numerator of our exponent. So we have x to the 15 over the number outside of the radical is going to go on our denominator. So we're going to have x to the 15th over 5 over y to the 10th over 5. All right, and that's going to simplify to x cubed over y squared. And that's our final answer. So if you understand this rule here, where we take this number over that number in the exponent, we can just skip that second step and just go straight to x to the third over y squared. If you recognize that we can simplify that to 1 and a 3 and 1 and a 2 because we're dividing them eventually. So if they go into each other evenly, like if the index goes into the power of our radicand evenly, we can just skip this second step here and go right to writing our answer. Okay, whatever way you prefer, you certainly don't have to do it that way. That's just a little shortcut you can use if you're comfortable. All right, and then we'll move on to number 3. The first thing I like to do is take care of that negative exponent right away. So I'm just going to rewrite this as 24 r s to the 2/3 power t cubed over 6 r to the 1/4 power. Okay, so I just took the t to the negative third power in the denominator and moved it to the numerator and then made it positive. All right, the next thing I recognize is 24 and 6. We can simplify that, okay? So 6 goes into 24 4 times. So we have 4r s to the 2/3 t cubed over r to the 1/4 power. Even though it's not written there, we know that there's a 1 hiding there. And since 1 is bigger than 1/4, we're going to take the exponent 1 and subtract 1/4 from it in the numerator. So that's going to look like 4 to the r 1 minus 1/4 s to the 2/3 t cubed, and 1 minus 1/4 is 3/4. So we're going to have 4 times r to the 3/4 power s to the 2/3 power t cubed. The last two examples we'll look at today are number 7 and number 8. Okay, so 7 looks kind of familiar to a few problems that we've already done so far. So we should know by now that the first step is to take the fifth root of the numerator and the fifth root of the denominator. So I do not want to have a root in the denominator, so what I'm going to need to do is rationalize. So I need to multiply the numerator and the denominator by something in order to get rid of the fifth root in the denominator. So I know I'm going to be multiplying by the fifth root of h to the something. And now I need to figure out what power am I going to raise h to so we no longer have a radical in the denominator. So when we multiply these together, since they have the same base, an h here and an h here, we're going to add the exponents. And I'm looking for a number that's a multiple of 5. Okay, because it's the fifth root, we want a multiple of 5 so we can simplify and get rid of the radical. So I'm going to do h cubed. And if you don't understand why I'm doing that, you'll see in just a second. On the numerator, I'll have the fifth root of g squared h cubed. And in the denominator, I'll have the fifth root of h to the 7 plus 3 power because I'm adding those exponents together, so it's going to be h to the 10th. So since 10 is a multiple of 5, we can do what we did in this example up here, where we're able to reduce the power under the radical and the index. So we're going to do the same thing. Sorry if that was kind of hard to follow there. We're going to do the same thing in this example here. So we can rewrite this because that'll cancel. We're left with a 1 and a 2. We can rewrite this as the 5th root of g squared h cubed over h squared. And that's our final answer. Okay, in this next example, it also looks familiar to a few of the problems we've done today. So notice here we have a fraction. The numerator and the denominator have the same base, and we have different powers. So the first thing you want to recognize is which power is bigger. Okay, 1/4 or 1/5. Okay, 1/4 is bigger. So what we're going to do is rewrite this as x to the 1/4 minus the power of our denominator, which is 1/5. Okay, and in order to subtract or add fractions, we need to have common denominators. So we're looking for a number that both 5 and 4, a common multiple of 5 and 4, and that is 20. So I'm going to multiply that by 5/5 and this fraction by 4/4. So we're going to get x to the 5/20 minus 4/20. Common denominators, we can just subtract the numerator, so we're left with x to the 1/20. And that is our final answer. And that concludes the notes for 7.2 part 2.